Hi, I'm Eniac, a computer node from MSU's newest research cluster. I'm here on a special assignment to describe how nodes like me work. Nodes like me are just a special kind of computer that doesn't have a graphical user interface or display accessory. Most people have computers in their house, car, pocket, or on their hands. But do you really know how a computer works under the hood? Like all computers, a node does four things really well. Firstly, it accepts inputs that you give it by tapping on the screen, typing on a keyboard, talking into a microphone, or even by listening and sensing. Secondly, it stores data that it needs in its RAM or hard drive. Thirdly, it processes this data using programs written by humans with its CPU. And lastly, it outputs the processed data to a screen or save file in its hard disk. Now this process may seem simple, but like all robots, you'll see that the speed at which computers process large volumes of information make them invaluable for scientific discovery. So, what makes computers so fast or powerful? What makes one computer faster than another? To answer this question, let's take a closer look under the hood and compare the hardware in a desktop computer versus the hardware in a supercomputing node. On the motherboard, in addition to lots of tiny circuits, we can see the fan and the heatsink. If we remove the fans and heatsink, you can see the central processing unit or CPU. This is a bit like the brain of the computer. It performs calculations based on the instructions that programmers give it. Modern CPUs are subdivided into multiple cores, and each core has its own independent processing unit. CPUs with multiple cores form a unit sometimes called a socket. In a home computer, the CPU typically has one socket and can have up to 8 cores. In a supercomputer, one compute node has at least 2 sockets, each with multiple cores. And on HPCC, each socket has 10 to 14 processing units. Currently, desktop computers with X-core CPUs can process 10 billion math operations per second, while the human brain is only capable of less than 1,000 operations per second. That means it would take a person almost 3 hours to do what a desktop computer can do in a single second. In a supercomputer node, each processor is no faster than your desktop computer, but with more than 2 to 3 times the number of processors available, a node can accomplish tasks faster if you're able to divide up the work among its numerous processors. For researchers, this means we can speed up the time to scientific discovery. Random access memory, or RAM, is the main memory of the computer. When you run a program, like email or a game, the short-term memory, RAM, is where the instructions to be processed are stored. Aside from the memory located directly on the CPU chip along with the processors, RAM is the fastest memory in a computer because it sits very close to the processor. The more RAM a computer has, the more efficient it is at doing larger or multiple tasks at the same time, like streaming a video while chatting over Messenger and playing a game all at the same time. A typical home computer has upwards of 16 to 32 gigabytes of RAM. 1 gigabyte holds the equivalent of approximately 4,500 200-page books. A single node in a supercomputer typically has upwards of 128 gigabytes of RAM. This means that a supercomputer node can hold larger programs in memory for processing, so we can solve bigger problems with it than on a regular computer, thus again speeding up this time to scientific discovery. The hard disk is used for storing data that we need to reuse or access even after the computer is switched off. A typical desktop has only a single hard disk, but a node can have multiple, allowing much more data to be stored on the node for processing. This means that a lot more persistent data is stored closer to the processing unit without having to use a networked or external disk. A typical home computer has about 1/4 to 1/2 terabyte of disk. That is equivalent to all the materials in a standard home library. A single node in a supercomputer can have a minimum of 1/2 terabyte of disk space. Because we are able to access more data faster on a single node, programs that require reading and writing of data out to many small files can run much faster on a single node than on a desktop computer. So, now you know what a computer does, the hardware that helps it do these things, and what makes a single node in a supercomputer faster than a desktop computer. So maybe you're wondering, how can we increase the hardware in a node, like the number of CPUs, RAM, and storage, so that we can solve even larger problems? This would require multiple nodes working in unison to solve the problem together. Desktops and laptops connect to other computers via Wi-Fi or Ethernet cables. Nodes can be connected with other nodes by means of a high-speed network connection called InfiniBand. This network transfers data at 50 times faster than Ethernet, and makes sending messages from one node to another node very fast. So although multiple computers are involved in solving a problem, the delay in sharing information is greatly reduced, and you can almost believe that all the nodes are acting as a single computer. In fact, we have a very special name for this fully connected system of nodes. It's called a supercomputer.